Hello, this is a quick data science project that we worked on just over a year ago, where we tried to do churn analysis on a particular bank application. Now, the problem stated is that now there was a high churn rate on the particular banking app, and we're trying to devise ways for us to reduce this churn by using targeted communications, either via email or push messaging or web messaging. Now, the problem, the problem was to uh, solve it. We're going to solve this problem in three different categories, right? The first one is to having access to the data, gathering the key data that will be required to create the model. The second will be creating a model that will classify a customer's probability to churn into three categories. One is unlikely to churn, the other is likely to churn, and the third is very likely to churn. Now, having done this classification, the next step would be to create dynamic communications based on these three different classes, using the customer's information in terms of his biometrics, in terms of his activities on the platform, or in terms of his general account status, to communicate to them, so that they can interact, they can feel connected to the bank. Now, these three classes of for the data that we're going to be working, that we worked with, we had three different classes. We had the general customer data, which basically consists of his biometrics, which is his age, the gender, the account type that he has, or the account types if he has more than one, the product that he has subscribed to. So we have all these data stored in a particular repository on a SQL server somewhere. Now, the second key, source of data will be what we call the analytical profile of that particular customer, which is we need to know what is his average balance over the last 3 months, what are his total number of outflows, his total number of inflows in terms of frequency, what is the value of his outflows and the value of inflows in terms of, value of the transaction itself. Now, this information gives us a general understanding of the analytical, we'll call an analytical profile of that particular customer. Now, the third set of data that was used for this particular task was us, bringing together information about the customer's activity on the app itself, right? So we wanted to know how frequently does this customer log into the app? When he logs into the app, what does he do? Does he look at his balance? Does he do his transactions using the app? Does he buy uh, data from the app? Does he buy minutes in terms of telecoms for his phone and all of that, right? So this is the third group. We had all this data moved through a particular pipeline and stored in a particular repository. So this pipeline is being run on a weekly basis, and we have that data in that particular repository ready for us to use. Now, having the data in the repository made it easy for us to access it and use it to build our model. Typically we built two main models. We built a support vector classifier, and with the probabilities. So we did the EDAs and got performance of over 80% accuracy. We also looked at the the F1 score, for instance, the recall and all of that, right? So just leave that, and have a performance of over 80% accuracy, which was great. We also built a neural network model. The initial one was using a sequential model, which slightly outperformed the machine learning model. It uses more data, but it also runs on a it also uses more computational power than the machine level and takes more time to run. We compared these two models and chose the neural network model for the simple reason that it outperformed the machine learning model. In this instance, knowing fully well that we'll be running this model just once a month, we had time on our hands. We didn't have time constraint, and we didn't have a processing power limitation. So we stuck with the artificial neural network model, and and use that for our final deployment of the process. Now, having the what I'll call the result here, which is a data table of of the of the classification that was done. Oh, just to mention, our classes was created using the probabilities. So from 0 to 0.5 we classified as unlikely to churn. From 0.5 to 0.75 we classified as just likely to churn, and from 0.75 and above we classified as very likely to churn. And those three classes was used in the final three classes of the model.